Okay, Unit 15 review. So this test is all about converting between logs and exponentials, and then understanding that the inverse of an exponential function, the ones we did last unit, are the log functions, and knowing their domain, range, and all the attributes. Okay, so if you're going to express something in log form, you first have to know what the base is. So for instance, the base here is 3. Now, a lot of people don't like it when the equal sign's on this side, so you can actually even write it like this. Okay, so a lot of teachers use that saying, the base is the base, and the other switch place. So for this one, the base was 3, so I'm going to do log base 3, and then these two switch, so x equals y. Alright, on the next one, we have the exact same thing. Now again, this one's written a little different, so a lot of people do like to kind of flip it and put that over here. Okay, so again, the base stays the base and the other switch place. So 8 is your base. I'm going to switch it to a log form. So I'm going to have log base 8 of 512 is 3. Alright, on the next one again, I can rewrite it. I've got x to the third power equals 10, and again my base is 3. So again, the base is the base, and then the other switch place. Okay, now in this one I am going to express it in exponential form. So again, you have to know what the base is. Now this one doesn't have a base, so it's understood to be 10, so you could write it like that. Okay, and then if I switch it into that exponential form, the base is the base, so 10. And then the other switch place, so 10 to the power y equals x. Okay, same thing here. There's my base. Okay, so the base stays the base, so the base here is 2, and then the other switch place. Alright, same thing on this one. I'm changing it into exponential form. So again, the base is the base. Now, with this natural log, it's actually kind of written like this. So if you think about it this way, it's sometimes a little bit easier. Very rarely you'll see this because it is the natural log, that ln, but the base is e. So the base stays the base, and then the other switch place. Okay, on the next one, we've got key attributes. Now for pre-AP, they will not be able to use a calculator, but Level will. So sometimes the easiest thing to do, so you can get a picture, is if you actually put this in your calculator. So here I'm going to do math, alpha A. The base is 2, and then x plus 5. Okay, and if I just kind of get a picture of that, I can kind of look at it right there, and I kind of see where it's at. So the first one is the domain. So for this one, my asymptote is going to be at -5. So if you kind of draw a picture, it's about right there at -5. So because of my vertical asymptote being at -5, that means that I can't go past -5. So -5 to infinity. It is a log function, so they're all real numbers, or -infinity to infinity. Okay, for my x-intercept, it's crossing right here, and it moved over 4. Because remember, for the parent function, the asymptote is at 1, 0. So it moved over 5 to -4. And the only transformation that happened is it went left 5. Okay, on the next one, again, it helps to sometimes put it in the calculator so you can take a look at it. So on this one, I'm going to put a parenthesis there, and then +5, so it's a little bit different. It kind of looks the same, but it is different. Alright, and then if I graph that, again, something doesn't look right there. Oh, I see what I did. Let me get rid of that. Okay. I'm just going to clear that and redo that since it's becoming a big issue. Alright, so math alpha A, log of 10, because there's nothing there, and then x, and then +5. Okay, now you'll be able to tell this one does look a little bit different, so it went up 5. Okay, so nothing happened to your domain, so it's still going to be 0 to infinity. Range is always going to be negative infinity to infinity. And then your VA, because the domain is 0, is just going to be x equals 0. All right, on this one here for your transformations, the only thing that happened was it went up 5. All right, on this one here for the domain, now the domain is connected to this, okay, and so is the VA. So I can tell it went right 3, so I know my domain is going to be 3 to infinity. And again, that range is always negative infinity to infinity. And then again, these are all related, so x equals 3. And then I got 2 transformations. I know it went right 3, and I also know it went up 1. All right, down here I am writing the inverse of each function. So with this one, it's actually kind of easy because, again, I know the inverse is going to be an exponential. So I can actually say the inverse notation is the base stays the base, and then the other switch place. All right, on the next one, now I'm actually going to work this one out. So this is really y equals e to the power of x plus 2, and then you switch them. And then I'm going to subtract 2. So that gives me x minus 2, I'm going to put that in parentheses, equals e to the power of y. And then what I actually end up with is I know that the inverse of that Euler's number is going to be a natural log. So my final answer is y equals the natural log of x minus 2. But again, you want to write it in that inverse notation. So f of negative 1, and then x minus 2. Okay. All right, so for this one, this is a lot of, just pretty much putting in your calculator and taking a look at it. Now, this is a parent function. So what I know about all log parent functions, because remember, this is really log base e, is that the x-intercept is at 1, 0. I also know that the VA is x equals 0. This is a parent function, so there aren't any transformations. That's your most basic one. Again, the range is going to be that all real numbers, or negative infinity to infinity. And then your domain is going to be 0 to infinity. Now, if I'm going to graph this, what I'm going to do is I'm going to put up a vertical asymptote. I'm going to really make sure I have that x-intercept. And then I'm just going to kind of sketch my graph, especially if you don't have a calculator. I'm just going to kind of sketch my graph so it looks similar to it. Okay, now this one here, I can tell that this one's actually not moving. And then also if I write it like this, say I just put in x plus 0 there, minus 5. And again, last page I told you that this is connected, and this is connected. So what I can actually notice here is that I'm still going to have my VA at 0, because nothing's happening on the inside, which means my domain's going to be 0 to infinity. The range is always negative infinity to infinity. And then the only transformation I had is down 5. Now, if I wanted to put this in my calculator, I would have that. And I can go to my table and just pick a few good points. So I have a good point at 1, negative 5. Okay? And then at this point, I'm just going to pretty much just sort of try to just kind of estimate about where it is. Okay, on this one here, again, my domain is going to be related to this, which is related to this, which is related to this. So I know it moved left 4, so negative 4 to infinity, which means x equals negative 4, and then the range, negative infinity to infinity. Okay? And again, as far as graphing goes, really the best thing to do is to just put in your calculator. And for pre-AP, you'll just really need to worry about moving this, so moving that x-intercept without that. All right, and I see I have a point at 0, -1. And I'm actually going to put up that asymptote at -4 right now. So I got to make sure my curve does not cross that. And I also have a nice point at 4, 0. And let me see if I can maybe get one more nice point. So -2, -2. And then I'm just going to kind of just draw my curve and just make sure it approaches that asymptote. Okay, so again, just getting points. All right, now for this one, I'm graphing the inverse. Now the inverse of an exponential is a log, okay? So the inverse of this would be, the base stays the base, so log base 2 of x, okay? So if I'm going to graph this one, again, I know this is a parent function. So there's my asymptote, which means my domain has to be 0 to infinity. And again, because it's a logarithmic function, -infinity to infinity. And again, the other thing I know about parent functions is that x-intercept is at 1, 0. So I'm going to put that x-intercept right here. Now, if you wanted to, you could come over here. Let's see if I can get lucky and just kind of delete all this without it being too much of a hassle. All right, so there's my function. And again, if you want to just come over here and just pick a few good points. So 4, 2. And then just kind of draw your curve. I think maybe I can get 9, see 8, 3 out of that. And then just kind of draw the curve. Okay? All right, on the back. All right, so these are just, again, evaluating. So I'm going to actually do it by hand. The way that I'm going to want to do this is what my x is. This is my f of x, so x and x, okay? So I would do log base 5 of 125, okay, equals x. So I would need to find out 5 to what power equals 125. And the answer would be 3. 5 times 5 times 5. Okay? Now in this one here, you would have log base 5 of 1 over 25, okay, equals x. So that would be 5 to the power of x equals 1 over 25. So 5 squared, so 2, would give me 25, but since I want it flipped, it would be -2. All right, now pre-AP we'll have to do this by hand. So use these two examples to help you to get to the rest of the answers. For level, you will be able to use your calculator, so let me show you how that will look. So here you're going to do your math, go to your log base, okay. I see that there's nothing here, so I know it'll be a 10. And the first one is 1,000. So pretty much 10 to what power will give you 1,000, and it's 3. Same thing on this one. Now I'm going to actually use this log button instead. Okay, so on this one, it would be 1 over 100,000, and you get -5. All right, this one here got log base 4, so math alpha A is going to be 4, and then 16, and you get 2. All right, this one here, I'm going to have math alpha A again. I'm going to do log base 4, and then 1 divided by 64. And you get -3. Okay, on these two word problems, I'm going to try to make this as basic as possible, but these can be, they look tricky, but they're really not. All right, so here you've got decibels. And then you've got this formula right here. So I've got a log. And I'm going to be dividing, okay? So what I'm going to be dividing is I'm going to be dividing an I sub 0, or I naught, by the number of times, okay? So times the number of times over, again, the I sub naught. Alright, so all I'm gonna really do here is I'm just gonna cancel these out. That gives me log 100. Okay, so that's what my decibels will equal. Notice how there's not a base here. So remember, when there's not a base, it's understood to be 10. Okay, so what I'm really trying to figure out here then is 10 to what power will give me 100. And then x will equal 2. 10 times 10. Alright, same thing on the bottom. Talking about the Richter scale, earthquakes. Okay, so we're going to have log. Again, have that I sub naught, I sub 0. This time it's 1,000 times. Okay. Divided by the I sub naught. Going to do that. Again, I have log 1,000. Again, there's not a base, so it's understood to be a 10. Okay, so basically what I'm trying to do here is 10 to the power of x equals 1,000, and then x would equal 3. 10 times 10 times 10 will give you that 1,000. Okay, I hope this helped you. If you need any help, make sure you ask your teachers. We're here to help you, and that's really about it. Good luck on it.